All right, here we go. So, problem number 1. Find all of the asymptotes. So that means vertical and horizontal. So probably like usual, we'll start by factoring anything that will factor. So of course the top doesn't factor, but the bottom will. So I will factor the bottom like this. Now remember, you have two kinds of asymptotes. You have vertical asymptotes and horizontal asymptotes. Your vertical ones, if you want to move a chair over here, sweetie, so you can see, just move it around or sit over here. So vertical asymptotes come from the denominator. So I'm going to have 2 of them. X cannot be -5 and X cannot be -1. My horizontal asymptote comes from comparing the top X's and the bottom X's. What do you notice about the bottom X's? They're bigger than the top. The top is plain X, the bottom is X squared. Whenever the bottom is bigger, the asymptote is at 0. So the horizontal asymptote is at 0. If they matched, if we had had 4x squared over x squared, if we'd had that situation, then the asymptote would be at y equals 4. But the bottom one was bigger, so the asymptote is at y equals 0. Okay, I can't do this. Okay, so make a little note and I'll help you when I'm done. Okay, otherwise I'll never get it all videoed. Okay. All right, we'll go through the problems. That's what we're doing. So find the remainder. Now, this is a tricky one because when I say find remainder, you are all going to probably want to divide, and that is absolutely fine. The problem is, look at this. When you go to divide, you got to remember to put in a 0 because there is a power missing. Do you see that? If you're going to do synthetic division, you have got to pay attention to any powers that have been skipped. So now I can divide. So I bring the 2 straight down, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, and the remainder is that last number, which would be 47. 3 is a 2-part question. It says find the y-intercept. Now, it doesn't matter what the equation looks like. It could be as hard or as easy an equation as you can imagine. If you want a y-intercept, you are going to do what? Let x be 0. That's how we find y-intercepts all the time. We let x be 0. So, I don't care what the equation looks like, I'm going to let x be 0. So if I put a 0 in for the x, what does this part equal right here? That's just 1. So I have 80 over 1 plus 4. That's 80 over 5, which is 16. So my y-intercept is at 16. Now, what do you need to remember? To find a y-intercept, you let x be 0. So, to find a y-intercept, I let x be 0. There we go. All the x's are 0. That's how you find a y-intercept. So, -1 squared is 1 times 3, so that y-intercept is at 3. Now I'm going to solve an absolute value. So the first thing I'll want to do, you can imagine, is add 3. Your teacher last year might have said that's isolating the absolute value. You're getting the absolute value by itself. You add 3. And then if you want to break that into 2 pieces, you certainly can. So 2x minus 4 equals 9, or 2x minus 4 equals -9. So 2x equals 13, x equals 13 halves. Absolute values are going to have 2 answers. And this time the 2 answers are 13 halves and and negative 5/2. So 2x minus 4 equals 9. 2x minus 4 equals negative 9. That is your strategy. This one, we talked about this yesterday, can also be split apart into two pieces, just like this one was, if you want to, but I think it's harder to do that. Your job is to get x by itself. You want x alone. So you need to get rid of the 1. So let's just subtract 1. Just remember to subtract it all the way across. So take 1 away from here, 1 away from here, 1 away from here. And then to get x alone, you're going to need to divide by 2. So negative 5/2 is less than x is less than or equal to 7. Right? And be careful, because this is going to be a multiple choice question, and the answer may not be written that way. The answer may be written like this, right? That's your interval notation. So you need to be aware that that can be written both ways. Number 6. Speaking of both ways, you can solve this in different ways. It just says solve. It doesn't say how you have to do it. It's a quadratic equation. So what is your thought on how to solve this? There are options. You could try to factor. Now, I can tell by looking at this, and maybe you can or maybe you can't, so you'll try factoring. It's not going to factor. This does not factor. So factoring is a wonderful option. If it works, do it. But what if it doesn't work, like this one doesn't? Then we can use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It wouldn't hurt you to write the quadratic formula down. I've done it so many times. I can kind of just do it, but you haven't done it as many times as I have, so you might want to write it down. You might also want to put down what A, B, and C are. So A is 1 in this problem, B is negative 3, and C is negative 5. So when you plug your numbers in, that's all there is to it. If you don't have the formula memorized, you're sunk, of course, because I'm not going to give that to you. Now we just simplify. So 3 plus or minus the square root of, that's going to become a positive, so it's going to be 29. You can't do anything with that, so that is just your answer. There's no simplifying to do with a 29. Domain. What do we need to remember about domain? The denominator can never equal 0. The denominator can never equal 0. So x plus 7 cannot be 0, which means x cannot be negative 7. So every number is okay except negative 7. Negative 7 will not be allowed as an x value, a domain value, in this problem. Okay, now we got some function. And we need to evaluate x minus 2. Now, what does that mean? What does evaluating a function always mean? Plug in, whatever they tell you to plug in. So if this said find f of 5, we would plug in 5. It doesn't. It says find f of x minus 2. So we're going to put in x minus 2 wherever we see an x. So 2x minus 2 squared plus 7x minus 2 plus 1. Every time you see an x, you put in whatever they tell you to put in. In this case, it's an x minus 2. Okay? So we have 2. Now I'm going to FOIL this. X minus 2 times x minus 2. That's a FOIL. Don't get lazy. So x squared minus 4x plus 4. And then I'll distribute. And I'll collect like terms. And whatever I get, which I don't know, I was talking, I hope that's right. Double check me there. Whatever I get, that's the answer. Okay, we don't do anything with it, we don't factor it, we don't solve it, we don't do anything, we just stop. Right there. Did somebody match that? Did I do that okay? Yeah. All right.
Do you combine like terms?
You do, I did combine like terms. Now, 9 is actually almost the exact same, same problem. Nine is almost exactly the same. It says find f of g of x. That's the same as saying f of x plus 5. Because isn't g of x plus 5? So we're going to do exactly what we just did. We're going to take out, we're going up to f, taking out the x's and putting in x plus 5's. So we have x plus 5 squared minus 2x plus 5 plus 3. That's exactly what we just did here. We're taking out the x's and plugging in x plus 5. So again, we have a FOIL. That's x plus 5 times x plus 5. FOIL it out. Do your distributive. And collect like terms. So this time, x squared plus 8x, 18. Double check that for me. But again, that's it. Don't do anything, just stop. The question said, what happens when you put in x plus 5? That's what happens. Nothing else to do. Number 10, easy, easy, easy. Number 10. Put your name on this and pass it around. Just write your name on it. Okay, so number 10. We're going to graph this. What shape is this? Notice it's a square. So what shape is it? It's a parabola. Now, tell me about this parabola. Normally, a normal parabola looks like this. That's what a normal parabola looks like. What happened to this one? It's upside down and left 2 and down 1. So left 2, down 1, upside down. There it is, finished. If you forget your rules and you forget that it's a parabola, left 2, down 1, and all that, then to graph it, you'll have to set up a T-chart and plot some points. Because otherwise you won't get a graph. But if you can remember it's a parabola and it's been translated, you absolutely can just sketch it right away. Speaking of parabolas, how do we find the vertex of a parabola? Somebody studied negative b over 2a is how we find the x-coordinate anyway of the vertex. So in our problem, negative b over 2a would be negative 1. The x-coordinate is negative 1. Okay, so then the y-coordinate I will find by plugging in. So what's negative 1 squared? 1 plus 6 times negative 1 minus 1. So that's 3 minus 6 minus 1, which is negative 4. So the question is, what's the vertex? The answer is negative 1, negative 4. And we got that by finding x, negative b over 2a, and then plugging that into the function. Alright? What equation would show the following transformations applied to y equals x squared? So we're going to have an x squared equation, but we've shifted it left 2. Alright, how do I do that? Left 2. X plus 2. So I have x plus 2 squared. Now it's left 2, just like this. Oh, this one was also left 2, right? Alright. Vertical stretch by 3. That means you're going to make it 3 times taller. How do you do that? 3 times. Multipliers. If you are stretching, you have to put a multiplier on your problem. So, stretching or shrinking. If you're changing the size, it's a multiply. And then vertical shift down 1? Minus 1. So there's your equation. That is the equation that moves you 2 left, 1 down, 3 times as tall. Alright.
So we put 3 tiny answers there?
This is the answer. That's the answer. It says write the equation. So that would be the equation. Alright, so now I am going to plot some points here so get this thing graphed. Okay, now I need to find the intervals where it is decreasing. Alright, so what does decreasing mean? Going down. So just start at the beginning of the picture. Would you say I'm going down? Yes. Okay, but I stop going down here, don't I? I'm not going down, but here I start going down again. So those 2 purple sections are the decreasing sections. Would you agree with that? So what are the x values for those decreasing sections? There's 2 of them. The x values are from negative 3 to negative 1. I'm doing x values. I'm going left to right, and then I start decreasing again at 1 and go all the way to 4. Those are my decreasing intervals. That's what the question asked for. If it had asked for the increasing interval, there's only one of them, right? There's only one place on this picture where my pencil's going up, and that would be from negative 1 to 1. Remember, when you write that interval, it is the x's you are writing. They're labeled there on the picture for you. The x's are the ones you're using. Find the x-intercepts. At what point does the curve just touch or bounce on the x-axis? Alright, let's go ahead and sketch this because we can answer all the questions from the sketch, even though it doesn't tell us we have to sketch. Where do I put the x-intercepts, or the dots on the number line? Where do they go? At negative 1 and 3. Yep, 3, 0. Those are my x-intercepts. So the first question said, find the x-intercepts. Done. Now, if I sketch this in, remember, it's a cube. If you FOIL it out, it would be a cube, x cubed. And what do we know about x cubes? How do they start and end? Starts down, ends up. So this guy starts down here. Okay. What happens when he hits this point? Your choices are he goes through or he bounces off. Well, that came from this. That's squared. So that means it bounces off. And what does it do when it hits this one? That one goes through because it's not squared. The 3 is not squared. So when the question says, At what point does the curve just touch the x-axis? The answer would be at the point -1, 0. On the other review sheet, it said, where is it tangent to the x-axis? That means the same thing. Think of tangent as bounce. Okay, number 15. Find the inverse. Notice when I wrote the equation, I wrote it with a y instead of an f of x. Is that okay? So I wrote it with a y. Now I'm going to find the inverse. So what are my steps to finding the inverse? Switch the variables. Oops, and then get y by itself. So just do the arithmetic to get y by itself. Okay? Not too bad. Write in exponent form. That means do it. Get rid of the logarithm. Make it a regular equation. So to do that, you need to remember there's a base in there. What's the base? E. So e to the x equals 16. Now you don't have to solve that. You could, but you don't have to. It says write in exponent form. This is now written in exponent form. That's all there is to it. E to the x equals 16. All right, we talked about this yesterday also. We got this beautiful little equation here, but we want to write it as one logarithm. So in other words, all of the 8's and x's and y's and all that have to go in that parentheses. Before we start, we have to do one thing. What is the one thing? Who remembers from yesterday? The 2 has to become an exponent. So ln 8 plus ln x squared minus ln y. That's step 1. You've got to do, if you have a coefficient, a number in front of the logarithm, you got to deal with it. Now you can start putting it all together. So you're going to combine the 8, the x squared, and the y. How are they going to get combined? 8 times x squared divided by y. Because pluses become multiplications, and pluses become multiplications, and subtractions become divisions. That's how it works. Now we're actually going to do a sketch, but this won't be bad because we already practiced on that last problem that I just erased. Step 1. Before we can start sketching, we have to do something. What do we have to do? Factor it. And this one, you can take out an x. And once you take out the x, this is exactly like the one we did yesterday. Once we take out the x, we can factor that as the difference of squares. Now I'm going to sketch it. So I start by putting the dots on the number line. Where are the dots going to go on the number line? At -3, 0. +3, 0. And 0. Right there at the origin. Now, are any of these factors squared? No. So the fact that nothing is squared means when I graph it, what's going to happen? Everything's going straight through. Nothing's bouncing. So all I have to know is where to start. It's an x cubed. Where did you tell me x cubed start? Down. So here we go, down, there it is. We are finished. That is your sketch. That's all there is to it. Okay, a few more no calculator problems, and we'll get the calculators out. So number 19 says solve this equation. This is, you should remember this. This is the very last stuff we did. How do we solve this equation? Loop-de-loo it. That's right, we want to loop-de-loo it. So what's it going to be? 4 to the second equals 3x plus 1. Is this exactly the same problem I did already?
Yes, it is.
Gosh. So 16 equals 3x plus 1, and 15 equals 3x, and x equals 5 is the answer to the question. But no matter what numbers I stick in there, you've got this, right? You've got that figured out. Okay. Now I'm simplifying. Alright, so what's my strategy going to be here? When I simplify this, I'm going to FOIL. I'm going to FOIL. So, first times first, outsides, insides, lasts. Now, the tricky part is in there now. The foiling is easy. You've been doing that since you were about 12. But, what about I squared? I squared is -1. So you are not going to leave that as -12I squared. You're going to say it's -12 times -1, so that is just a +12. -12I squared is +12, which can be added to the 10 to make a 22. And these two can be added together to make -7i. So the answer to the problem is 22 minus 7i. What property is shown? All right, pay attention. I know there are parentheses in there, but have we regrouped or have we changed the order? We changed the order. And if we change the order, it is commutative. Think of grouping, like when you group yourselves in the room right now, you grouped yourselves, you associated yourselves with each other. Grouping is associative. Order is commutative. All right, and then we've got the last one here, which is a big one. As I copy it down, I am going to factor that last thing, that last denominator. I'm going to factor that. That's not new to us. We know we usually factor. If it factors, we factor it. Now, I do not like all these fractions. It makes it seem like it's a very hard problem. So I'm going to get rid of the fractions. And I'm going to get rid of them by multiplying everything by x plus 1, x minus 2. Now, some of you don't want to take the time to write that down. That's your prerogative. I'm going to write it down every time. Because now I can see stuff cancels. So I'm left with x minus 2, plus 3, x plus 1, equals 5. So by multiplying through by the common denominator, I was able to get rid of everything in the denominators. They're gone, no more fractions. So now I'll just do my distributives and collect like terms and get it equal to 0. You know, I always like to have it equal to 0. I think I had it right. And then I have to solve it. I'm not done. I have to solve it. So it's a quadratic. Does it factor? Because if it does, that might be the fastest way to do it. It factors. X plus 2, x minus 1. What if I don't like to factor or it doesn't factor? I'll use my quadratic formula, right? And then I'm ready to solve. So what are my solutions? X equals -2 or +1. Now, neither of these are extraneous, but we can get extraneous roots on these. Remember how that happens? If we had gotten -1 as an answer, what happens if we put -1 in here? We get a 0 on the bottom, and that's not allowed. So whatever answers you get, you might want to go back up and check to make sure that nothing ends up giving you a 0 in the denominator. Okay, now we're ready for the thing. Now we're going to get questions later, and we don't have time for many because we got to get the exam started. But here we go. Number 23. Now we're going to get our calculators out. And we got all these problems to do with a calculator. So here we go. Here we go. So here's our function. And we have to list the possible rational roots and then find them. So here we go. So what are the PRRs? Factors of 27 over factors of 3, right? And that would include 1, 3, 9, and 27, but also 1/3 and 3/3 and 9/3 and 27/3. Remember, your PRRs are factors of your last over factors of your first. Now we have to actually find them. So what do? Start plugging them in, and it looks like maybe 1 works. Always start with 1 and -1. Start simple. Don't be picking big numbers, even though you will have a calculator on this. Don't pick big ugly numbers. Does that give me 0, I think? So what do? Now I know that one of them is 0, or one of them is 1, because 1 gave me 0. So what do I do with it? I divide it out. So let's divide it out. And again, make sure when you're doing your synthetic division that if any powers are skipped, make sure you put in zeros. Here we go. All right, so we knew that was going to happen. We knew we were going to get a 0 as our remainder. We're all good with that. What is this that's left over here? 3x squared plus 27. Now we need to solve that. You could keep guessing, but I wouldn't recommend it. It's a quadratic. You have other ways to solve quadratics, right? Other than guessing. You have a formula you can use. I don't think that factors. However, this is the kind that if you wanted to, could you just take the square root of both sides? So I think it's easiest to solve this. Now keep in mind, you can use the quadratic formula. You could even complete the square. But because there's no middle term, it's easiest to subtract 27, divide by 3, and take the square root. Now, what's that? Watch it, it's -9. It's the square root of -9, so it's going to be plus or minus 3i. Your job was to find the answers. There are 3 of them. 2 of them are right here. Where's the other one? right here. So when you have an answer blank and says write down the answers, you're gonna put 1 and plus or minus 3i. Now this is a free response question, so you're gonna have, you're gonna show all your work and all that. But ultimately, these are the answers to the question. These were your possibles, and these are your actuals. All right, number 24. How do we solve an equation that looks like this? Take the natural log of both sides. X is in the exponent, so the only way to solve is to get the x down, and the only way to get the x down is to ln both sides, because this will cancel, and you'll be left with this. So 3x equals ln 10 minus 1, and x equals ln 10 minus 1 over 3. Now when you type that in, do not divide until you hit equals. It's ln 10 minus 1 equals divided by 3. And the answer you get should be ln 10 minus 1 divided by 3. ln 10 minus 1 0.4342. All right, that should be the answer you come up with. To the nearest dollar, find the amount you would have from investing $1,200 at 3.1% compounded monthly for 10 years. Now, I'm going to put a couple formulas on the board. One of them is the PERT formula, and then there's that other one. Which one do I need for this problem, number 25? I need the other one. It's not a PERT problem. Remember, you will PERT under two circumstances. You'll PERT if the problem says continuously. If the word continuously is in the problem, you're going to PERT. Or if it's not money. If it's not money, you're automatically going to PERT. Well, this is money, and it doesn't say continuously, so I'm going to use this formula. Find the amount you would have if you invested $1,200 at an interest rate of 0.031. Do not put 3.1, it's 0.031 divided by 12, why 12, monthly, and it's up to 120 power. The power is 120 because the power is 12 times 10, right? So now I just type that in. I don't need any logarithms. I don't need anything weird. I like to start with the parentheses, but you don't have to. And I ended up with an answer of 1635.46. Oh wait, did it say to the nearest dollar?
Yeah.
Okay, so if it says to the nearest dollar, then I need 1635, $1,635, since it says to the nearest dollar.
How do you type that in your calculator?
Type the parentheses, hit equals, base it to 120, and times 1,200. All right, number 26. Find the growth constant for a strain of bacteria. Okay, this is another formula problem. Which formula am I going to use with number 26? That's my PERT. It is not money, so I'm going to use PERT. I start with 154 and I end with 912. It takes 3.5 hours for that to happen, and my job is to find R. Right? Now, I had the same situation I had a minute ago. My variable is up here in the exponent. I'm gonna need logarithms because I gotta get it down. But I can't get that r down until I get rid of that. So step one is divide. As soon as you divide it, then we can do what? ln, natural log both sides. So we're going to ln this fraction, and over here, that 3.5 comes down, and now I can solve for r by simply dividing by 3.5. So I'll get ln 912 divided by 154, and then divided by 3.5. I came up with 0.5082. Did I do that right? By the way, that's a huge, that is like a 50% growth rate. That's a pretty big growth rate, isn't it? All right, write the equation of the line through these 2 points. Write the equation of the line through these 2 points. Now, there are going to be some problems that you're going to find hard. This should not be one of them. How do we write the equation of a line? We find the slope. So the slope is 8 minus 6 over 4 minus 5. So -2 for my slope. And then what? That is not the answer. We're not done. So I can use slope intercept form. Y equals mx plus b. And I can plug in -2 for my slope. And then I'll pick a point. I'll just use that one. So 6, that's the y value. 6 equals -2 times 5 plus b. I got b equals 16. So my answer would be y equals -2x plus 16. Could I have used that point and gotten exactly the same answer? Yep. Could you have used the point slope form instead of slope intercept? Yep. You have options. An item is marked 83.20 in the store. Find the final cost if there's a 20% discount and a 7% tax. So I'm going to start with 83.20 and I'm going to multiply it by 2 things. One of the things I'm going to multiply it by is a discount. Discount is 1 minus. The other thing I'm going to multiply it by is a tax, which is 1 plus. 1 minus means I'm taking some away. 1 plus means I'm adding extra on. Obviously, a discount, I'm taking away something. When you have to pay tax, they are adding on something. So, what was my discount? 20%. So that's going to be 0.80. 1 minus 20%. My tax is 0.07, so this is going to be 1.07. I will then calculate that number. Now, you are free to do this problem. If you have other strategies, you may certainly use them. However, round-off error does matter, so I will be looking for exactly the same answer that I get, which is $71.22. When I multiply all those numbers together. How many gallons of an 8% solution should be added to 100 gallons to get a 65? Okay. Our formula is amount times percent plus amount times percent equals amount times percent. Now, we've done that enough times. Even if you don't have a clue what's going on, you can write that down. And every time it says percent, you can put a number in, right? So percent, I got a 8%, so 0.08. Remember, every time we use a percent in a problem, no matter what kind of problem it is, every time we use a percent, it goes in as a decimal. How much of an 8% should be added to a 90%, so that's 0.90, to get a 65%. There we go. That part, I mean, if you can read, you can do that. That's easy. Now, how many gallons, so that'll be my x, that's my unknown, how many gallons of the 8 am I adding to 100 gallons of the 90? The only thing missing is right here. What goes right here? 100 plus x. Your empty space, for lack of a better word, the empty parentheses will either be here, 100 plus x, or in some problems it's here, which would be 100 minus x. Now we just go solve it. So 0.08x plus 90 equals 65 plus 0.65x. You have a calculator, so you can be using your calculator. Hopefully I subtracted right. And then x is going to equal 25 over 0.57. I did that in my head. Did I do my subtraction right? And it's about 43.86 gallons. So 43.86 gallons is how much you're going to have to add in there to get that percentage. All right, and then we are almost done. We've got a couple more to go. So number 30 is one of our big exponents. Now remember, on all of these, you can get partial credit, so you definitely want to get as much down as you can. There's a lot that needs to be done here. I suggest, it's completely up to you, but I suggest that when we simplify it, we work inside here first, get all that's a mess in there. Let's get it combined. So I've got my 4 and my 3. You don't have to do it in this order, but I think it might be easier. Now I've got my x's. See these negative ones? They're going up, but there's already 5 up there, so that will leave me with 8 of them. Now, same thing's going to happen to my y's, except these are coming down, so I'll have 9 of them on the bottom. These 2 come down. And then my z's, these 7 are going up, so that would be z to the 8th. And that's still a mess, but it's better than that, right? So all the negatives are gone, we combined everything. So now we're ready to square. So that's 16 x to the 16th, z to the 16th, over 9 y to the 18th. 4 squared, 3 squared, that's 16 and 9. And then you are doubling x to the 8th, so you have x to the 16th, z to the 16th, y to the 18th. And then the box problem. Now I did not copy this on the exam page like I did on the other one. But let's refresh our memory what that's going to look like on the exam page. It's going to ask you, okay, how big is the paper?
Oh
yeah, it asks all the same questions. The only thing, yeah. Yeah, all right, so it's ready. So the paper's 20 by 16. So here we go. 20 by 16 is the paper. So step one, write an equation. So the volume of the box is going to be three things. Always three things because it's length, width, and height. So if the paper's 20 by 16, what are the three things? 20 minus 2x, 16 minus 2x, and x. So question number one, write the equation for the volume of the box. That is it. That's all you have to do. Now the domain, that's where you figure out what x has to be between. X has to be between what in this problem? The paper's 20 by 16. 0 and 8. It's always 0 and half the smaller dimension. What viewing windows, because we know eventually we're going to have to graph this, because you know we're looking for a maximum. So what viewing window? This is X-min and X-max. That's already done. X-min and X-max are already calculated. You already figured that out. You also already have Y-min, because it is always going to be 0 because it's the volume. Now, Y-max, not a clue. I'm going to pick a number. I'm going to pick 500. Now, maybe it'll work, maybe it won't. If it doesn't, I change it. It's not a big deal. So I go to my window and I put those numbers in. 0 to 8 and 0 to 500. 500 is Mrs. Ford's guess. You could guess a different number. I'm going to put in my equation. 20 minus 2x, 16 minus 2x, and x. And I'm going to graph it. And lo and behold, I should go buy a lottery ticket today. I got lucky. I can see the top of my hill. Now, a lot of times when you do this, you get a picture that looks like this, right? Which means you didn't go high enough. You got to go high enough on that Y-max to see the top of the hill. Could you have picked 600 and been okay? Yeah, anything bigger than 5, because 500 works, anything bigger than 500 will work, right? So there are lots of numbers. Just pick one and see if you can see the hill. If you can't, pick a bigger one. And keep picking them till you get it. The last question says, what size corners should we cut to maximize? So I'm going to graph this picture, and now I want to find my maximum, right? And how do I do that? Second calc, pick maximum, set your left bound and your right bound, and my maximum is 2.94, comma, 420.11. Now, we need to answer the question. Which one is the answer to the question? It's either going to be 2.94 or 420. What size corners should we cut out? That's X. X is the corners. I didn't draw the picture because I've drawn it so many times. But X is the corners, right? So what size are the corners we should cut out? 2.94 inches. That is the size of the corners. Huh? That's the volume. Y is the volume. So if it said what is the maximum volume, then you're going to choose your Y number. X is the corners, Y is the volume. All right. Now, how many of you are planning to stay to take the exam? Well, let me ask this question. How many are not? How many are not? So that's 1, 2, 3, 6, 7, 8. I'm just trying to figure out if I can stay in this room or if I need to move. I think with 8 of you gone, I think I'll be okay. Actually, maybe we will go to the cafeteria. So We'll take, I'll take questions for 10 minutes and then we're moving to the cafeteria. So if you have a question, bring it up here and ask me. Phil, you are at the end of the line if you've got your late.
I'm sorry.
Yep, not acceptable. You're at the end of the line. When I'm done with everybody who's here on time. Then you can.
For this one, if it was like 1/2 instead of 2, and like what would happen with the x's? Like if
Nothing happens with the x's.
Oh, it'd be half. Oh, okay.
They would just be a square root.
Like if it was
There was 4 9s. I was just trying to get it to 1/2, then it would be 2. She just said she wanted to. Okay, so remind me.
Because it's like the same.
Bailey, why are you?
Do you not?
Yeah. Daisy, did you stop that video? I don't need that online.